Okay, so hello everyone. Welcome to this webinar on how to simplify your workflow with FME custom transformers. My name is Mark Ireland. I'm the FME evangelist. That's what I'm called. If it's not my official job title, but I talk to a lot of people about FME. So, and with me today, I have my colleague. Do you want to say hi?
Hi everyone, I'm Sanai. I'm a technical support specialist on the FME server team.
Excellent. And Elizabeth, you're here as the webinar organizer to keep us going correctly and keep us up to speed and everything.
Happy to be joining you guys this morning.
Yeah, and in the background we have our colleague Dave Campanas, who is a long-time FME expert, even longer use than I've used it for. And you can see by the grey in my beard, I've used it for a long time. And so Dave's like really expert. So he's in the Q&A panel today. If you've got any questions about custom transformers, or even mapping files, I'm sure he's the guy to be able to help you there. So yeah, please do chat out your questions. I see we've got some more folk tuning in from the Netherlands and from Ireland. Donegal, beautiful place. Okay, well, what are we going to cover today? We are going to look at what is a custom transformer. We're going to build one just to do a very quick demo. And then we're going to look through the three main uses, which are clarity, modularity, and functionality. And then we'll round off with best practices. And I'm going to do the first couple of bits, the let's build one and the clarity. Sanai's going to do the modularity and functionality, and then we're going to flip back to me to do best practices. So that's the agenda for today. If you're completely new to FME, I mean, this focuses on a very specific piece of functionality, but that's okay. Just you might struggle to understand some of the technology or the terms that we're using, but just sort of get your head around the idea of these. And if you're a bit more experienced in FME and you've used it before, then hopefully you'll get a good grounding in custom transformers and some of the things they can do. But this is a fairly basic level webinar today. But you can ask any questions you like, obviously. So shall we turn off our cameras? I suspect everyone's seen enough of us. I'm going to turn mine off.
Sounds good.
Okay, and so what is the problem we're trying to solve? Well, sometimes it's difficult to organize and maintain a workspace at scale, what do we mean by that? Well, it's easy enough when you've got a very small workspace with half a dozen transformers in. We can just run that and it's fine to put together. We don't need to do a lot to it. But once you start scaling up to dozens or maybe even hundreds of transformers, that's when it becomes more important to employ some best practices. And custom transformers are one of those practices that can really help you keep things organized while you're scaling up your workspace and scaling up to bigger and bigger projects as well. So what is a custom transformer? Well, a custom transformer is when you make a new transformer. That's fantastic because, I mean, we've got a lot of FME transformers, but sometimes they're not exactly quite what you need and you need to add a little extra. Well, you can do that. Do you need to know any coding? Well, no, because we're actually making these new transformers out of a series of existing transformers. So we say we've got our data integration workflow, we wrap up part of it into a custom transformer, and that becomes like a module that we can use again and again, and other benefits that you'll see as we go on. And so, yeah, you could call it like a sub workspace or a module or a subroutine if you're into programming, that sort of thing. Yeah, and when you think of it like that, it sort of helps because obviously you have a big workspace. If you can break it down into little modules, it becomes a little bit more easier to manage. And again, the whole point of all this is to scale up a project more easily. I mean, there's lots of uses for custom transformers, but really that's the end goal, is to make sure you're organized and you can scale up your projects. And yeah, custom transformers, you can make them really quickly, but they have a huge effect on your work. So let's build one just for those folk who maybe not familiar with FME or not familiar with custom transformers. Let me see. Oh, I thought I had an FME started somewhere. There we go. So we're going to build a custom transformer today. So what am I going to do with this? Well, I've got some data that I'm going to drag and drop into here, and it's some parks data from the city of Vancouver, and it's a zip file in map info tab format. And if you followed any demos that we do online, very often we use this this data set because it's nice and simple. And yeah. So if I run this workspace, all I've got so far is I'm reading some data that looks like this. There's a whole bunch of parks in there, and there's a spatial part. Okay, so maybe I want to do something with this data. So I want to calculate the area of some of these parks. So I'm going to calculate the area, and I'm going to write it to an attribute called park area. And then I'm going to say, well, maybe I want to calculate some statistics about those. So I'm going to put down a statistics calculator, and we are going to analyze the park area that we just measured. And we're going to find the minimum park size, the maximum, the sum of the parks, and the mean or the average size of those parks. And I'm going to turn on group processing, which means we're going to do this on a group basis, grouped by neighborhood name. In other words, I'm going to get a result for every different neighborhood in Vancouver. I'm going to find out this information. And I'm just going to attach these to junction transformers just to, actually, I'm just going to connect it to one of them. I only need one for now. I'm going to hit the run button on that. And here are the results of this. So downtown has got this park area, Fairview has got that, and blah, blah, blah. Okay, so that's all good. So where does the custom transformer part come into it? Well, maybe I want to make this into a custom transformer. The reasons for doing that we'll explore in more detail later, but it's a simple enough task. I just select the transformers that I want to put into this custom transformer. I press Control T, or I select it from the menu bar under transformers, and it pops up with this. And I can say this is a mean area measurer or calculator or something like that. And I can give this transformer a category. You'll notice that all of the transformers in FME have a different category, and I can assign this new transformer that I create to any one of those categories, or I could create my own category like webinars and put it under there. And we can put a description in, which again we'll look at shortly, but really this just describes what this does. That's what we put in there. Okay, so when I click OK, FME creates a custom transformer. And here we are. We have a new tab opens up in our workbench. So that's the main tab. This is the custom transformer tab. This is a definition of our custom transformer. You see the two transformers we had already are in here. We have these green objects, which are input and output ports. And if I go back to the main tab, I can see now that we've got a custom transformer, which is denoted by it being this different green color. And these are the input and output ports. Again, I can go back into this transformer and I can double click on these and just change the name to be like input and output. That will be easy enough to do. You can see that they've changed in there now. And I can also add a new output. Say I want this complete port to be output as well. I can just right click and say, oh, let's create a new output. And I can rename that to complete maybe and connect that up. In fact, maybe I should rename that first one to summary. That would make more sense. Did I put 3 M's in there? I did. There we go, click OK. And there you are, you see we've got the summary and the complete outputs now. So that really is just a very basic way of creating a custom transformer, and we get the same results out of there again: the minimum park size, the maximum, the sum, and the mean. And yeah, and we could even make edits in here, make changes, like we say, okay, I want to calculate the total number of parks as well. And when we get in here, we can run that and get the same result out of here. So 19 parks, 5 parks, 8 parks, and so on. So yeah, that was a very, very basic example of building a custom transformer, just to show you how it works. And so that's really what we're going to show today, is how building custom transformers like that can be very quick, but it can really simplify your workflow. It didn't make a lot of difference in that workspace, but it certainly helped. It says headache from disorganized data. I'd probably say it's a headache from disorganized workflows, and workspaces more than the data. But yeah, it's certainly a big help to your projects. And that's what our mission at Safe Software is all about, to help you maximize the value of our data. And here we interrupt our programming just for a brief word from our sponsor, just in case you're new to FME and want to know a bit more about the company Safe Software. So we've been together for nearly 30 years now. 1992, 93, we started up. Yeah, I mean, organizations in 128 countries around the world, hundreds of partners supporting our user network in so many different countries, so many different places. So pretty big growth over the last few years, I got to say. And yeah, the FME Integration Platform. Today we're going to use FME Desktop, which is just a tool to build and run data workflows, usually on your own computer. Then we have FME Server, which can run those models in an enterprise sort of way online. You can do automation and serve up data over the internet, that sort of thing. And then there's FME Cloud, which is the third part of that. And that does the same thing as FME Server, except it's based in the cloud and not on premises. So FME Server itself, you can install on a local server. FME Cloud, you can just install it as a cloud piece of software, and not even install it. You just fire it up and it's there. So yeah. So the desktop is where we author these models, and server and cloud is where we can run them if we so desire. And notice on the right hand side is a little phone there, just to show you that we do have some apps on the phone. One of them is FME Data Express, to help you with FME server and cloud workflows. And the other one is FME Augmented Reality, to overlay spatial data into your view of the world on a cell phone. And we've got some good demos of that. So yeah, and if you're not familiar with FME, well then that's the background. And we support so many different types of data. It's unbelievable. We specialize in spatial data, but there's a lot more besides that we can do. So we started out with GIS and CAD, but yeah, I mean, now we've got indoor mapping, there's gaming, there's the Internet of Things, all sorts of things that we can pull together and process. So that was a quick word from our sponsor. Somebody just asked, could we do that again? Because it was so simple. And yeah, I can just hit the undo button a few times and just show you very quickly how to do that again. Just select the two transformers, press Control and T. There's my dialog comes up. I'm going to call it Average Size Calculator. And there's my custom transformer, like so. And we can rename the input and output ports just by double clicking them in here. Oops, that's input, not output. But anyway, you get the idea. So yeah, so the three main uses though for a custom transformer, what are they? Well, clarity is really making sure your translations are clean and tidy, and that's what I'll cover first of all. Modularity means being able to reuse them. and Sanai is going to cover that. And also she's going to cover the advanced functionality, which will be things like loops and web APIs and things like that, which really are a lot easier sometimes to use a custom transformer for. Okay, so let's look at clarity. What is clarity? Well, clarity is making your workspace or making your project tidier. Tidier means it's easier to read, it's easier to understand, it's easier to edit and maintain, because obviously most workspaces are dynamic. You don't just create them once and leave them. You go back and you edit them and you update them. And so trust me, coming back to a workspace in 6 months' time, if it's difficult to read, you're going to have a real problem updating it, even if it was you who created it in the first place. So this is what clarity is all about. Now, you may have noticed that we've got this idea in FME Workbench of a bookmark and a collapsed bookmark. And so one of the questions we could ask is, well, how does a custom transformer differ from a collapsed bookmark? And people ask that because they've seen it and it looks very similar. So what we're going to do is we'll take a look at that in a moment. I'll demo the differences. But from a clarity point of view, it's not hugely different, but there are some key differences. So we're going to look at that in a second. The other question that often comes up is, how does handling parameters differ in a custom transformer? And that's something that's fairly straightforward as well, and we'll show how that works. So now we'll go to a quick demo. So I'm going to open up a starting workspace. And here we've basically got what we had before. We've got the parks data, the average size calculator, and I've thrown in actually an attribute rounded transformer, because when we run this, you'll see the output from the from that calculator we created had like 9 decimal places, which is very precise and that's lovely, but we don't really need that. So the attribute rounder rounds it off to 3 decimal places. And then we have this other transformer called the number separator, which is another custom transformer. You can tell by the color of it. And what that does is it separates numbers out, big numbers, by putting the commas in the place. So I don't know if you can see in the table view at the bottom of here, the maximum park size in the West End is 4049129.768. Or after it's run through the number separator, it's 4,049,129.768 meters squared. So it's a good way to create a label that's a bit more readable. So that's what that transformer is doing. Okay, so what does that number separator look like? Well, we can click on its tab up here. Remember, we can see all custom transformers in their tab up here. There's the area average size calculator. This is the number separator, and you can see it's a bit bigger than the other transformers, and it's got bookmarks in it and annotation, but yeah, there's quite a lot going on in there. So that's a good example straight away of how it keeps your main canvas free of clutter, because we didn't have to put all of that on the main canvas. We keep it in a separate tab, and it makes this one tidier. So that's really what this is all about in terms of clarity. Now we have the idea of a collapsed bookmark, and that's what this is. This is basically the same content as the number separated custom transformer, but put into a bookmark. And from a clarity point of view, there's not a great deal of difference. You don't get a separate tab for a collapsed bookmark. It just appears on screen. And if you want to look at the contents, you can click on the button and expand it, and there's all the same content in there. And we can collapse that bookmark and expand it, collapse and expand as we need. So really, it is just another way of collapsing or resizing a series of transformers and squishing it down to make it more clear. So really, from that point of view, there's not a great deal of difference between a custom transformer and this collapsed bookmark idea. The big difference is that if you want to make an edit, you have to open it up in here, and things could get moved around in the numbers in the collapsed bookmark. So that is one bit of a drawback. The other thing as well is if you want to repeat these sections again and again, you would have, and then make an edit, you'd have to edit each one of them in turn. And this is something Sanai is going to show later. But if you have multiple instances of the same custom transformer, you can just edit the definition and they'll all change. So in other words, all of these transformers point to one single definition. A collapsed bookmark will each have their own definition. So that's another difference. The other question was about parameters. How do they work? Well, you can see in here in the number separator, we have a bunch of parameters come up, just like any other transformer. So how do we get those parameters to appear? How do they work? So I'm going to go into the average size calculator. I'm going to look in the area calculator transformer, and there's a parameter in there called multiplier. And I'm thinking, well, wouldn't it be great if the user could enter a multiplier for the custom transformer as a whole? So all I do here is click on the drop-down arrow, user parameter, create user parameter, and I can just click OK on that. And now when I go back to the main canvas and click on the parameters for that custom transformer, the multiplier setting has been made available. It's been published inside the custom transformer so that I can set it outside. And now the benefit of that is that I can make changes to that parameter here, and I don't have to go into the definition and start looking around for that parameter to change it manually inside here. So that's the advantage of doing that. And especially when your transformers for a different user than you are, that's one of the reasons why we would do that. So yeah, that is pretty much clarity. I think someone mentioned a collapsed bookmark uses less temporary space. Yeah, that's a sort of a technical thing, but you're right, because if I run this workspace, oops, hang on, I should have had that connected. Let me run that workspace again. So all of the little green windows are caches, and if I look inside the transformer itself, you'll see that the data got cached at every different step. So it's using memory up to store the data at every different step there. Whereas on a collapsed bookmark, we only get the output there right at the end. So it's not caching everything in between. So it does save a little bit of memory when you run the workspace. But yeah, that's could be useful, could not, but that's one of the differences as well. Bit of a more technical one. Anyway, that's excuse me, that's clarity. Yeah, that's hopefully that was interesting to you. Just there are a couple of questions that I'm just going to answer. Would that user parameter be able to be different in every instance? Well, yes, that's probably true. They would be able to be different, and Sanai will show you that. So really, the thing we learned there is there's no definite rules about when to use those two different types of functions. Generally, I use collapsed bookmarks in smaller areas of workspace, and custom transformers will be bigger sections. I'd use it where parameters aren't needed, because then you can set it on the custom transformer directly, whereas you'd have to search through the bookmark to find it. And also you would use it where modularity is not a concern, because, well, we're going to see that shortly. Well, we're going to see that right now, because I'm going to hand over to my colleague Sanai to take over the presentation and explain all about modularity and custom transformers.
Yeah,
Sanai.
thanks, Mark. Yeah, I'm going to build on clarity with modularity, and I think it will speak to some of the questions that have come up about how having multiple custom transformers in one workspace or many workspaces work. So I'll just take over the presentation. Okay, so modularity. It's probably most often thought about as a software design concept, but it really can be applied to a lot of things, including FME workflows. It's about organizing a workflow into independent, interchangeable pieces, each with its own job. Custom transformers are definitely created and managed using principles of modularity, which we'll see shortly. One way we can start thinking about modularity is in the way that we edit our transformers. So when you create and save a custom transformer, it has a single primary definition, which we saw in the tabs in the last demos, but you can reuse instances of it throughout your workflows. And when we make edits to its definition, those edits are reflected across all instances of that transformer. So this is really helpful for updates, fixing bugs, general upkeep, just tweaking things. It also means that we have to be thoughtful of who is using that transformer and where if we shared it out. There's two ways to store a custom transformer. Embedded custom transformers can be recognized by that green color. They're stored with the workspace, but they're separated into their own tabs. They're a great organizational tool if you have a repeating process specific to that workflow, but there's also some advanced workflow functionality like looping that's only available to embedded transformers, and we'll look at that a bit later. Once a custom transformer is put into linked mode, and you can tell that by that light blue color, it's exported to a file external to the workspace with an FMX extension. The FMX file is then really easy to share with others, and when you make edits to its workflow definition, every workspace that contains that linked transformer can be updated. You can also specify which mode that the transformer will automatically use and then toggle between these modes. So if you need to just tweak a custom transformer for one workflow, just switch it back to embedded. You can also have both modes inside of one workspace. So we know embedded transformers are stored inside of the workspace, so that's not very convenient to share between your own workspaces or with others. But once it's in linked mode, we have better options. So the FMX file is automatically exported to a default FME directory, and you can find this file, send it to others, and then they can store it in the same folder to use it inside of their workbench. But since they now have their own stored definition, they won't get the updates that you make to yours. So if you'd prefer that everyone is using the same copy and to manage edits from one definition, place the FMX file in a shared folder on a network or a cloud so that others can access it from their own workbench. And if you made something really neat that you think would be useful to others, we definitely encourage you to upload it to our sharing platform, the FME Hub. That website has all of our latest user and safe software created custom content. Sometimes we put some of our experimental stuff up there, stuff that isn't shipped with the product, but we think could be helpful. Definitely take a look around. And you can access this from directly inside of Workbench too. And I'll show you that in our next demo. When you download link transformers from FME Hub, they'll also get any updates pushed from the hub. You can also manage updates by saving custom transformers to different versions. So all of these versions are going to be saved in that FMX file. So it's possible to roll back to older versions when needed, as long as it's compatible. So let's say that we have a routine process that we've created an embedded custom transformer for. And we know our coworkers are still doing it all their own ways, sometimes to different results. We can get everyone on the same page by exporting our custom transformer into linked mode so that everyone's results will be consistent and it'll be easy to manage and update should the workflow change. So in this demo, we're not going to do anything really flashy. We're just going to see how these concepts of sharing and editing custom transformers look in practice. So let's go over to FME Workbench. So here we have that same parks layer that we were looking at in the previous demo. It's a workhorse, it's a good one. And we're also calculating their areas in square meters. Let's say that we have a customer who's consistently requesting unusual units for their maps. So we're always looking up different conversion ratios every time, and maybe that's getting annoying. So we've built our own custom transformer that does that for us, called the best ever area unit converter. And in here, we can just put in our input units, which in this case is square meters. And then we have a selection of output units that we might use, say barns, baronies, rood, square chains, lots I have never heard before. Let's just use square yards. It's kind of vaguely familiar. And then we can use the area as the input value. If you work with any of these unusual units, please tell us more about that in the chat. I'd especially be interested in something like the barns unit. So we know that this transformer that we've created is embedded because it's green. So if I right click and edit, it'll open in this tab. And inside we can view just a pretty simple workflow. It takes in our values and then it maps them to the respective ratios for these units. And then it builds an expression to convert them into our output units. And then it returns the result back to the workspace. And let's say we want to include maybe another unit with our results. So we could duplicate this custom transformer. And they're different in name. And I can choose a different output. Let's do square chain. And we can see there's this number 2. But duplicates of the same transformer in the same workspace still share the same definition. So if we try to edit this second transformer, it'll still open in the same tab as the first. And this sort of speaks to this concept of modularity. And following this lot, any edits to the primary definition are going to be reflected in both transformers. So if we edit the input and output port names, we can do that as an example. And that'll be reflected in both transformers, which we'll see. But before we go back to our main workspace, I'll just mention that it's really good practice to maintain documentation for your custom transformers. So especially for others, but even for ourselves to keep track of what we've done. So we can write in documentation, we can use Markdown, just a description about what it's for, how to use it, and we can also add a version history. And now we can see that I am not the original creator of the area unit creator transformer. Let's see, updated port names, just a description of what I've done. This transformer is actually pretty old. We can see 2012, but it has a really simple purpose and design, so it hasn't needed much upkeep over the years. So I'll just select OK. And when we go back to our main workspace, we can see that those port updates are reflected in both instances of that custom transformer. And we can view our documentation by selecting the Help button. And this will look familiar to anyone who's ever looked at the Help button inside of a regular transformer. And here is our version history here with our updated port names 2021 that we just did. So when we're happy with this custom transformer, we can export it to a link transformer so that everyone else can use it. And we do that by just right-clicking the tab. And we can give it a unique name. We can select a category to organize it in the transformer gallery. We can also choose an insert mode, so that'll be linked or embedded by default or always. I'd recommend always choosing by default, just until you're very confident with your custom transformer design, since it sort of makes it restrictive in what you can do after the fact. So we'll do linked by default. You can set a password to stop others from editing and viewing the inside of this transformer. Maybe you want to monetize them, I don't know, patent them. And a save location, we can save this locally so that I have access to it, or we could save this to a shared location, as I mentioned before, so that others. I'll just select OK. We'll just take a moment to export. But link transformers are also stored in external files, so FME will automatically open that exported link transformer in a new workbench. And you can see this FMX extension at the top here, which differs from the typical workbench FMW file. And once we're in here, we can manage everything just a lot like the embedded version really, or any workspace. But we have all of the custom transformer specific parameters over here in the navigator, like setting the description and our inputs and outputs, that kind of thing. So it does differ a little bit from a typical workbench file. So in our example scenario, if we were to add, say, another option for a unit conversion in here, all our workspaces that reference this definition would be able to use it. It would automatically update in those workspaces if it's compatible. And back in our workspace, we can see that our link transformers are now this shiny new blue color, and our tab is gone because it's no longer stored with the workspace. If we were to go to the FME Hub and upload this, if we want to share it with the broader FME community or just store it on there for our own personal use, because we can make them private, you can go to this FME Hub website, which I'll recommend that you do. And I will look up the original area unit converter to see what that might look like. And here we see it on the Hub. It's quite popular, almost 1,000 downloads. Maybe this webinar will push it over to 1,000. And we can see our documentation here on the Hub, which is another reason why it's so important to do this for the end users. We can also see the history here of updates. We can comment on it. We can also set up a automatic sort of testing workspace to ensure that the transformer is always working. If it were to fail with a test, it can send you an email so that you can go quickly fix whatever's gone wrong, or investigate at least. So this concludes really how to export, update, and share custom transformers. Hopefully this all relates back to this original idea of modularity by separating out the repetitive processes of our workspaces and workflows into individual parts so that they can be reused and managed more easily. So our next sort of topic is functionality. Custom transformers aren't just for organization sharing, they also give us access to some advanced functionality in FME. So we can actually control our machine resources during translations with embedded custom transformers. So with parallel processing, we can tell our computer how to use more resources simultaneously. Multi-core processors allow us to do this. And when designed correctly, we can orchestrate much more efficient translations. Looping is another example of functionality unique to custom transformers, embedded specifically. So it allows you to repeat a workflow until you get a desired result. So you can think of this like an airplane circling a tarmac. The plane goes around and around, but only when the air traffic controller gives the okay will the plane exit the loop. You could also set this up so that the plane has to pass through this loop exactly 7 times before it lands. Or in this case, moves on to the next part of the translation, which would be the wheels down transformer. Either way, I'd highly recommend checking out our past webinar on looping transformers to learn more about this. And we can probably chat this out now or a bit later. So FME, as you know, supports a lot of formats and even more transformations, translations. But if you want to get creative, it's a great idea to wrap up scripting and command line tools inside of custom transformers. It allows us to obscure a lot of complexity and make user-friendly tools for custom formats and processes. And this also applies to API workflows. So if an application or a web service has an API, we can wrap up this request with a custom transformer so that it can be integrated directly with FME. So we can build in and manage all of the messy housekeeping that comes with web services. So every step of authentication, error handling, interpreting JSON and XML responses, and cleaning up all of the data is taken care of from inside of the transformer. This makes downstream processing a lot easier and the process of building a workspace that uses a web service a lot nicer. So that leads us into this next demo, which uses custom transformers as integration tools. So let's say we want to use a web service. If it has an API, we can essentially do anything with that web service that the API allows us to from inside of FME Workbench. And we can build a custom transformer that does this exact functionality that we want. This can save us time and prevent us from making mistakes when building future workflows, because I know I tend to, when setting up API requests, it takes a while to get things as needed, even if you've done it a million times. It's also useful for sharing web tools with others, especially when they aren't familiar with APIs. So let's go over to Workbench. So in this scenario, we have this list of address data. We need to fill out the empty resident and phone attributes with fake names and numbers. Maybe I'm going to use this data set for presentation or for testing a new database. There's lots of reasons to need and use randomized data. We don't want to use people's real names often. And we checked, and FME doesn't have a transformer for this. So what we can do is just search the internet and see what we can find. And in the process, maybe we find this website called the Random User Generator. And this looks like exactly what we need. It creates fake profiles, and it's a free service with an API. So we've watched all of Safe Software's API webinars at this point, so we're confident that we can do this with FME. First step is always to look at the documentation. Just a good habit. And if we scroll, we can see an example of making a request. There is the endpoint URL. And all of this response for the fake user is nested inside a JSON list called results. So back in the Workbench, the HTTP caller is the primary way that we can integrate APIs. And I'm just going to fill out this HTTP caller faster than I probably would the first time. But referencing the documentation, we are going to make a GET request to the random user website. So that was the URL that we saw on the website. We want to limit the results to just one. You'd also find that inside the documentation. And down here, I'm just going to set this concurrency option to 1 as well. Sometimes APIs have just limits on how often you can request information from them, especially when they're free, so we won't hammer that web service. Select OK, and I can run it right away because there was no authentication needed for this API. And if I run it, you can see that we're sampling 15 of those addresses, and it looks like we have 15 results here. And let's just see if I can see if that works. Oh, looks like it was successful. It's just taking a minute to load the results. I probably had my computer on for too long. Do that once more. But we're going to get a JSON response similar to what we saw in the documentation. Here we can see it now. And you can see that we have JSON nested in this results list. It's not super useful like this, but we can start seeing names, cities, numbers. We want to pull this information into our workspace, and we can use JSON transformers to do that quite quickly instead of hand-picking everything out. So we will select everything from inside that results list. And we want the first name, we want the last name, and we also would like a phone number. Okay. And we'll just check that we got that right. Okay. And here we have, yes, first name, last name, and our phone number will be somewhere in here. So we've correctly parsed out the JSON. And then lastly, our receiving database or end result, we want the name to be a single resident attribute. So I'll just use the attribute manager to do that. So we have our resident input attribute, and I could just build the first and last name using the results from that JSON fragmenter. So just concatenate those two things. And then I can remove all of the API information and that first and last name now that we've created the resident attribute. Press OK. Run it to the end. And now we can see that we have a first and last name, a phone number, and just the required information that we'd like to include for the receiving database. So the results look great, and if this is a web service that we could often make use of, let's make it into a reusable tool. So now we're familiar with this process, we can just highlight all of the transformers that we'd like to include in our custom transformer and select Create Custom Transformer, give it a unique name. So I'll create the random resident creator. And I'm going to put that in the integrations category since we're using a web service. I could fill out the documentation later, but I'll just select OK. And FME has automatically created this custom transformer for us, and it's opened in a new tab as embedded. And here we can see our new web tool in our workspace. And if I rerun it, we'll get the same results. But now we can share it with others. We can reuse it for other data, dummy data that we need, or we might use it as a prototype to tweak for any other requests we need to make to this same website. Maybe we'll have a bunch of different custom transformers for creating different parts of a person's profile, different endpoints, that kind of thing. Yeah, it could be a really handy tool to use in future workflows and share with others. And just as a disclaimer, if the API part of this demo was a little bit confusing, that's totally okay. It's mostly meant to show you that we could extend the functionality of FME using a third-party application and custom transformers. But if you would like to know more about APIs, definitely recommend our webinars on this topic. We also speak about custom transformer in some of those webinars because it's such a useful combination. But now I'll pass it back to Mark to talk about best practices. Very important part.
Fantastic. Thank you, Sinai. I'm just going to make myself the presenter. And here we go. You should see me now. Okay. So best practices. There's a few, well, it's quite a lot of different best practices we should be aware of. And this, I think, is really what differentiates a basic custom transformer from one that's sort of polished and professional. One of the things is designing for the end user, like who is going to use this custom transformer that you create. If it's yourself, well, okay, then it's less of an issue. But if it's for other people who may not have your level of FME skill, then it's more important that you help them be able to use this custom transformer. So how do I improve the usability? Well, you can provide published parameters for the user to input. We saw that before. I created a published parameter to enter a value, and it was easier for the end user because that way they didn't have to go in and edit the custom transformer. And that's really what we want to stop them doing. We don't want the user to have to edit the custom transformer itself to make changes that we should have been provided via a published parameter. In fact, we can even password protect the transformer so they can't edit it. We can make it linked only. So now I just showed that option there, linked or embedded. And that can get a little bit confusing as well because it's like, well, what do I export it at? What am I using it as? It's not necessarily the same thing as the user's using it as. So when I export it, I can say the end user is allowed to embed this, or the end user is only allowed to keep it linked. And if you keep it linked only, then that user can never edit that content. So you can stop them messing about with it if you want to. The other thing we can do is we can rename the input and output ports just to make it easier to understand what's going on. And I'll show that in the demo shortly. But I mean, all of the transformers in FME try to tell you what data is required to come in and what is required to go out, or what does come out. The other question is, what version of FME should I use? Because a user can't use your custom transformer if they've got an older FME. So for example, right now, if I create a transformer for the FME Hub, I'm using 2021.0 because even though I've got 2021.2 on my computer, I'm not going to assume that every single user who might want this transformer has upgraded to the very latest version of FME. So even if that version is out, I'm going to use the base version for creating those hub transformers, just so everyone can use them. What should go inside the custom transformer? That's another great question. And again, I'm going to show a demo, but usually I try and make a custom transformer generic so that anybody can use it. And sometimes there's functionality you think, well, I might use that there, but other people might not. So should I put this inside that transformer or not? And again, what can I leave out? Can I leave out something and expect a user to do it? That also applies, by the way, to loops. So now I showed that little image of a plane coming into land, and you loop around the airport half a dozen times, and then you put the wheels down and you go into land. One of the subtleties of that diagram is that the wheels down part is outside of the loop. It's not inside. So you don't loop around the airport. You don't say wheels down, loop around, wheels back up, loop around, wheels down, loop around, wheels back up. You only do the wheels once. You loop around and then you put the wheels down before you land. So it's important to make sure that only what needs to go in the loop goes in the loop, and the same thing with a custom transformer as a whole. Only what you need to put in there should go in there. And then you just make it a more generic tool. And again, I'll show that in a second, but what we're trying to do there is make it so anybody can use this custom transformer. If it's not for me, it's for an end user that we don't know who it is. We want to make it in a way that it's not specific to my scenario. So let's have a look at that. Really, we've looked at published parameters already, so we won't really cover that. But where are we? Here we are. So I'm going to open up this workspace. And again, it's the same workspace as before. We're calculating the average size of the parks. We're rounding them off. We are separating the numbers out. So the question is, well, what should I actually have put inside that custom transformer? For example, now I'm not actually working on parks. I've attached some neighborhoods data, which is different. The neighborhoods is KML format. So this is what the neighborhoods look like. And I'm just basically finding out the average size of each neighborhood in Vancouver. The thing is, coming from KML means this data is in latitude and longitude. And so the area of those features is 0.0004 square degrees, I guess it is. And when we round it off in the attribute, they all round off to 0. So really, in this case, I just need to reproject the data first. So does that mean I should put the reprojector inside that custom transformer? Will other people need to reproject the data as well? That's the sort of decision I'd have to make. Similar thing with the attribute rounder. Should I put the attribute rounder inside there? Would the user expect values to be rounded off or not? Should I put that number separator inside there? In this case, to be honest, I would take the attribute rounder out and I would put that inside here. And I'm going to have to put it in two places because we've got the two different outputs, but that's fine. I can do that. So that to me makes sense that I do this, because nearly everyone who uses this transformer will want to round those values off. but not everybody who uses that transformer is going to want to reproject their data first. So I'm going to leave that outside and say, well, the user should know. That's up to them. I'm not going to put it inside here. Now, if I rerun this, it's got the reprojector, that's built in. So the rounding's built in now, and we're good with that. And if the rounding shouldn't be in 3 decimal places, how can I fix that? Well, again, I can go to here and say, let's create a user parameter out of that. And now the user gets to choose how many decimal places. And for this one, I'm going to actually set it to the same user parameter, so we use the same value in both rounders. I'm not creating a user parameter twice. I'm just setting it to the same one. So now the user can set the number of decimal places to round it off to, and I can say 5 instead of 3, and that will apply to both of them. Like so. The input and output ports, actually, this comes up in the next section, but what we can do is say, well, input, what does input mean? Am I telling the user what I'm expecting from them? I could come in here and change that port instead of say input to say areas or polygons, or both if I like that. So I can say area dash polygons. And now the user's like, oh, now I see what that is. I know I shouldn't be putting lines or points in there now. And so, and again, we've got output summary and output complete. We don't have output 1 and 2 because what would output 1 and 2 mean to the user? It doesn't mean anything. And one other thing as well, notice that the output is called park area min, park area max, but I'm not using parks. So like, why call it that? So what I probably do to make it generic is to come into here and say, well, let's rename what's coming out of here. And instead of calling it park max area, we could just call it output maximum polygon size, or maximum polygon size, something like that. We'll do park area mean, and oops, what have I done there? Ooh, I got the help window, didn't mean that. Anyway, you get the idea. I could do park area mean, and we'll call that average polygon size. So basically I'm removing all references to parks, because I might be using it on parks, but other users might not be. So we're making this generic as we work on this. So yeah, so we genericize the output. We make the ports more easier to understand. We move things inside that we would think a user might expect the transformer to do, but we leave outside things that most users wouldn't want to do. Like most users wouldn't want to create labels with separated numbers, so we're going to leave that outside. So those are some of the things we think about for best practices. I'm going to rush through this very quickly because we're getting close to time now. If you do have to leave for the moment, then thank you for joining, and we'll keep recording this webinar so you can catch up on the end of it if you do have to leave now. Actually, I'm just going to escape from this, because if you do have to leave now, one of the things you might want is the webinar code. So I'm jumping forward to that slide just to say, if you want to get your badge on the FME community for watching this webinar, go to fme.ly/webinar badge, and today's code is SLGMB, and Elizabeth has chatted that out. And yeah, again, if you do have to leave now, thank you so much for attending this webinar. Hopefully it was useful, and please do give custom transformers a try. We'll send out all of the demos and the rest of the recording anyway, but just in case, yeah, please look for resources. They're there on the FME community or our technical support team. Okay, so I'm going to go back to, if you are able to stay with me, that's fantastic. So I'm going to move on to designing for reliability. What error trapping should we build in to prevent problems? Like, can we stop things happening before they happen. Like I can try this on my data and it works, but there's no guarantee that other people's data is going to work the same way. Like, am I making any assumptions about the input that would cause this to fail? Also, there's the rejected ports. Can we ignore them? Should we use them? How do we output problem data? Do we have a rejected port as well? And yes, we can do that. And we can set a rejection code the same as FME does. So let's have a quick demo of that as well. So we have the average size calculator. What could we say that we're assuming on this data? Well, one of the things we're assuming is that the user is sending in area features. We don't know that's going to happen. We're calculating the area of everything that's coming in, but maybe the user sent in points by mistake, or their area data has got a line in it by mistake that they don't realize is there. So what would that cause to happen in here? Would the data get thrown away? There's no rejected port, so we can't do anything with it. So maybe we should handle that by ourselves before and try and head off those type of problems. And again, this is really where we make this more professional. So what I'm going to do is put a geometry filter transformer in here. And I'm going to say, let's filter everything that is an area or an ellipse, because we can measure the area of an ellipse as well. And we'll let that through. But everything else is we're going to unfilter. And what I'm going to do is I'm going to create my own rejected port now. See, earlier we showed how to create output ports. And I'm going to right click and just say, just create our own port, call it rejected, and connect that output to it. So now if data's coming in that's not an area, we'll just output it and say this isn't an area, we can't do this. And that way, if it would cause any problems, we're heading them off before it even happens. And the other thing we can do with that is we can say, put an attribute, rename an attribute creator in there. What's the message again? I can't remember what it's called. FME rejection code. So every time you get an output from a rejected port, FME will create an attribute called FME rejection code. And I can create one of those manually as well. So I'm like sort of creating my own error trapping, if you like. And I could make a very brief message or a very long message. I could say this is not the geometry we are looking for. Or I could say not an area feature, not allowed, or I could do all sorts of things there. But we want polygons. And so when features come in that aren't a polygon, they'll come out of the rejected port with that message and say, okay, that's what the problem is. The other thing we can do is we can connect up some of the rejected ports on other transformers. And this is what I generally do, just because you don't know what's going to happen here. Like, what would cause an attribute rounder to reject a feature? I can think of a few reasons, but I don't know all of the reasons. And it could be that something happens that causes that to fail. So I might say, let's connect those ports up to the rejected port as well. So if anything does go wrong, it doesn't stop the translation, it just sends it out for the end user to deal with. It's sort of a just in case. And again, I could set a, well, maybe FME is automatically setting something, or I could set a message that says something like, I've got no idea, unknown error. I hate those messages, but in this case, we don't know what could happen. So we're just going to say, hey, unknown error, and send it to the rejected port. And I can do the same thing on here as well. Now, okay, we're starting to cross lines over a bit here, which is always a bad way of doing things. So what I often do is any connection that comes into the rejected port, I right click on the connection and just hide it. So now that's all hidden. I can see that they're going somewhere, and I can assume it's the rejected port here, and I can move the rejected port anywhere now. It doesn't really matter. I won't get any lines crossing over. And that's important, I think, for a design point of view. So yeah, so we try and pick out errors before they happen. We try and handle rejected ports so it doesn't cause things to crash. And now the user can deal with any output they want in that rejected place. The time zone extractor in this workspace is just an example of that. You can see I've got a rejected feature handling things coming here, and we can trace that back to where it comes from, which is here. So basically, if it's not latitude and longitude data, it'll send it out and reject that, and so on. So again, I keep saying again, but I'm going to try and stop saying that. It's one of the things I keep saying. But this is a great example of where you raise your custom transformers to the next level. It's just thinking about these things and trying to head problems off before they happen. And if you're going to put something on the FME Hub, it'll be really great to do that sort of thing, because otherwise people could download it, run it, and get an error message, and they're like, forget it. And it could be something simple that is just not handled quite right. And one of the final things I wanted to look at was designing for shared projects. A quote there from Jane Austen: "I shall be miserable if I have not an excellent FME library." Well, perhaps she didn't say FME, but she would have done if they had FME in that time. I'm sure she would have said that. So what do we mean? Well, I'm talking about how do you create a library of components? How do you create, how do you do version control? Do custom transformers help with shared projects? So one of the things I often do, if I've got a very large project and lots of people have to work on it, instead of keeping it as a single workspace where everyone's clashing with each other, you can split it up into multiple custom transformers, and then each person can take a different one of those custom transformers. I have an example that I can show on GitHub. This is a project I created about 5 years ago. It sort of does a best practice analysis on a workspace and tells you if the workspace is good or if it's got problems that you should try and clean up. I haven't touched it in quite a long while, so you would use this well, not your peril, but it's not guaranteed. Anyway, the point is that we've got this transformers folder, and I split every single different test that we used was split up into a separate custom transformer, and that way I could go away and make some edits to it, and other people could go away and make edits to a different test, and we could submit them back again, and we wouldn't clash or have to figure out what was changing. Now there is, I will mention, just in case you're wondering, there is a change detection and versioning tool coming up. Should be in 2022. I think it will certainly be in 2022. You can compare two FME files, FMW files. You can compare one against the other. You can visually view the changes. So you're going to be able to merge changes from one transformer or workspace to another. So that is coming up pretty soon. But in any case, you may want to do this. You may want to split your project up into smaller chunks so that individual different people can make edits to them. Let's see, what else did we have on here? Yeah, so version control libraries. That's pretty much it, I think. I think all we'll do now is we'll there you go. Here's one final quote for the day. This is from me. "There is no one FME tool that levels up your skills more than custom transformers." And I really believe that's true. Excuse me. I really don't think you can do better than to learn about custom transformers, because it just really elevates your use of FME to a higher level. it just lets you become more organized, more efficient in so many ways. It just helps with modularity, it helps with the functionality you can use, it helps with creating a clean and tidy workspace. It's just learn custom transformers, and it's a big deal. It really is. And so yeah, go and try them. FME 2021.2 is available, although most people probably have their own FME installed already. The workspaces from the webinar, we'll send them to you. We'll put them on the website anyway and send you a link. And yeah, so give them a go. Excuse me a second. And yeah, always look at the FME community and look at the knowledge base, because there will be a lot of things on there that you can find out about custom transformers. There isn't a specific custom transformer training module at the moment, but I know they're working on that for later next year. And if you're new to FME, we'll just mention quickly the different libraries different licenses you can use. Subscription license, which is basically you have an organization, you get a subscription, and anyone can use FME within that organization. Basically use it as much as you want. Perpetual license just basically means you have a fixed number of licenses, or you can deploy in the cloud. You can't deploy desktop in the cloud. You can only employ server in the cloud, but there's lots of pricing options there. So if you've got big jobs running, you can design them on desktop locally, run them on a cloud server, and there's all sorts of pricing options there that can make it cheaper for you. You only pay for that pay for the license when it's running and that sort of thing. I'm not a salesperson, you can tell, but if you're interested in that, check out safe.com/pricing for those sort of things. And yeah, the resources on the blog, we've got a blog post about custom transformers. If you're really interested in looping, there is a looping webinar. Like, there's a whole webinar about loops, so you can see how interesting that is. And there was also a whole webinar about sending calls to APIs without having to write code. So yeah, lots of resources. And don't forget the FME community as well. And don't forget the webinar badge too, which is SLGMB. So you can get that badge if you are a member of the FME community. We'll get to Q&A in a second. We just have to mention that the FME User Conference, or as we're calling it now, the Peak of Data Integration Conference, is in August of next year, and hopefully we will be all out of restrictions and everything by then, and you will be able to come to Vancouver, and it really is a fantastic event. I can't say enough about it. It's the Vancouver Convention Center. We get all these keynotes, all these different talks going on. You can talk to the development staff. It's just fantastic. So yeah, and the FME World Tour, that is where we send a whole bunch of staff to different cities around the world, and obviously that has been put on hold for a while, but next year we are planning to go back to real in-person tour events. So keep your fingers crossed that that goes ahead. And yeah, again, you can find that on our website, safe.com, find out more information. Okay, Q&A. So Sinai, David, was there any interesting questions that you wanted to talk about? I'm going to turn my camera back on so you can see I'm still here. Is anyone else still here? That's the question. There we go. There's Elizabeth.
Might just be you and me, Mark.
Okay. There's Sinai as well. I did notice quite a lot of questions that were really great.
Yeah, a lot of great questions this morning.
Yeah, one of them that I just wanted to sort of answer or to talk about was the difference between linked and embedded, and whether you should use linked or embedded, especially if you've got a custom transformer nested inside another one. That question came up a couple of times, and it really varies on the circumstances. If you've got a custom transformer that you're sharing as a linked transformer with people, and you've got another custom transformer nested inside it, I would usually make that embedded, because then you can share the original parent file around, and anything in it is just embedded and goes with it. But if you're using that embedded one, that nested one somewhere else, then you may want to just keep it as linked, because then the definition automatically gets updated. So yeah, that's there's no real right or wrong answer there from our point of view. It all depends on the circumstances. Sorry, I know I'm talking. Was there anything you saw, Sanai, that you were interested in?
Yeah, maybe I'm biased on this question because I'm on the server team, but somebody asked if there's any sort of special considerations for uploading workspaces that contain custom transformers to FME server. Good question. Embedded transformers, yeah, those definitions are stored with the workspace, so you're safe to upload those to FME server. Everything you need is contained in that workspace, so it'll all work as expected. Link transformers, though, we know are stored in a separate file, so we'll have to upload that file separately so that the reference in that workspace, FME server knows where to find it. We do have a step-by-step guide for uploading your custom transformers to FME server so that they can be used in different workflows, and I can throw that in the chat.
Fantastic. Okay, so where do we put them? We put them under files, resources, is that right?
Yes, I believe so.
Engine.
Yes, exactly.
Transformers. So you can put them into there. So no features tester, that's an interesting one. So I could upload a custom transformer if I've got one. I could find FME transformers like address abbreviation validator. I can publish that up to here, and now that becomes available to the engine. Or the other option is when I publish it through my Blue Sky connection, which passwords get longer and longer and longer as well. It drives me nuts. So I should be able to upload it. Do I do it here?
Yeah,
I think I do. I think I upload, I say add the file, and I add the FMX file here, and it gets uploaded into the same repository. I think, and so now you'd probably be able to know this better than me, but I think uploading it to the resources folder like this is a better bet, because then other workspaces can use it too. Is that?
Exactly, yeah. Okay. And honestly, that goes for all data that you're uploading to server. I'd always recommend putting it in sort of outside of the workspace folder in your resources somewhere, just so it's easier to find, reference in other workflows.
Yeah, I think that's a good way. One other question I noticed was about how do you, like if you've got a linked transformer and someone makes a change to it, how does FME know about that change? Generally, it can't know about that change. One of the ways to tell it is to shut FME Workbench down and then start it up again, in which case it'll look to see what's new. But the other thing we can do is right down at the bottom of the transformer gallery window, there's this little refresh button, and not many people seem to know about that. And what that does is that basically reloads FME's cache of what transformers are available. So if you know that changes have been made to a transformer and you just can't see them, you can hit the refresh button and FME will go away and say, okay, I'm just going to check, see what's new, and then it'll come up and say, okay, yes, there's a new version of this. Now you can download that new version or whatever. So, so yeah, that little button there, not many people know about it, and it's really useful with custom transformers. Anything else? I mean, I could talk about these questions all day, to be honest.
This could be its own AMA, Ask Me
It
Anything.
could. Well, we've got 60 people still online. I mean, I don't want to.
Oh, thanks everyone who stuck with us.
Yeah.
That's to the very end.
They say our tester transformer is ranked #1, but I think all our users rank higher than even than the tester transformer. You're that important to us and that great. So yeah, thanks for sticking with us. Yeah, let's. I don't know if we mentioned this. I don't know if Sinai mentioned it or not because I was probably busy answering questions at that point. But you can copy a custom transformer from one workspace to another just by copying it over. If I fire up another workbench, someone was saying, well, how do I copy a transformer and make it available in other workspaces? Well, okay, yes, you can export it or you can just copy and paste it.
Yeah.
And the copy and paste does work with embedded as well. So if it's embedded, you can still copy and paste. So it's just not a very efficient way of doing it, but it is a way of doing that anyway, of using one custom transformer in multiple workspaces.
Yeah. Just remember with embedded, if you make a change in the workspace that you copied it from, that change won't show up in the workspace that you copied
exactly, it. Yes. I don't know if we showed this either, that the the definition of a custom transformer that's embedded gets embedded in the workspace you're staying with. Okay, well, that's obvious. But if I delete the last instance of that transformer, it says, okay, I'm going to delete that transformer. Do you want to delete the definition as well? And I can say no to that, and I've still got that transformer in here. I can't actually see it, which is fairly pointless. But if I did the edit button, you can see it there. Now I delete it. I say, no, let's keep the definition. The definition is still in here, even though I've deleted all instances of that transformer. So the definition is like this separate thing that stays in your workspace unless you tell FME to delete it. That's more a little tip than a question that was asked. Let's see.
I think we've gotten to most questions now.
I think we have, yeah.
And if you do have any other questions after the webinar, definitely don't hesitate to reach out to us and connect with us on the community as well.
Yeah, please do. I mean, the community, you can ask plenty of questions there and lots of people there are answering them. And yeah, it's just please, if you create useful custom transformers, share them on the hub with other people. And yeah, fantastic.
Awesome. Thanks everyone for joining. And if you do have 20 seconds to complete the webinar survey at the end, we really appreciate any feedback.
Absolutely. Thank you, folks.
Yeah. Thanks, everyone.
Bye.
Bye for now.
Bye.